Okay. So once again, what we're going to do is kind of go back and redo all the where is something increasing, where is it decreasing, maxes, mins, concave up, concave down, but doing this from a graph rather than from a formula. I would like to take a look at the packet titled Analyzing Graphs of FF prime and F double prime. We have a graph over here, and I want to figure out where F's increasing, max, min, all that kind of stuff. What is this the graph of? Is this the graph of our original function, f? What is it the graph of? F prime. So I can't just say, well, where this thing is decreasing, f is decreasing, because this isn't f, this is f prime. I need to use some logic to kind of figure things out. I would like to write 2 notes at the top of the page that will not make a whole lot of sense initially, but will as we work our way through this example. 2 bullet points. First of all, to use the graph we have, look at the y values. To use the graph we have, look at the y values. To use the graph we have, look at the y values. The other idea that will somehow help us figure out all this kind of stuff is to use the derivative of the graph we have. We're going to look at the slope. To use the derivative of the graph we have, bless you, look at the slope. And somehow those 2 ideas will take us through this entire packet. Letter A. On what intervals is f increasing? Explain, just another way of saying justify and all that. Here's what we're going to do. We're going to go back to our definitions of all these things. The definition of f increasing is where f prime is positive. Where's f increasing? Well, I need to figure out where f prime is positive. We have the graph of f prime here, and I want to know where f prime is positive. I have the graph of f prime, and I want to know where f prime is positive. That means I need to look at the y values on my graph. Where is f prime positive? Well, I think it's positive over here, and I think it's positive over here. Do you see where I'm getting that? I think I should be looking at the intervals between 2 and 4, and then again between 6 and 9. And I realize that I already kind of did some explanation, but I really should have the explanation after I give my intervals. So I'm going to say that that's true because f prime is positive there. I'm looking at the y values. I'm not going to say the y values in my explanation, but that's how I'm looking at things and thinking about things. Are you with me so far? This is not the graph I actually care to know things about. The actual graph I want to know things about, I don't see. But this is going to help me understand that. Letter B. Where is there a local maximum and minimum? I haven't taught you that word, but what do you think local means? Relative. You need to see different language, but it's all the same thing. Relative max, relative min. What's the definition? Forget about this problem right now. What's the definition of f having a relative max? And there's a quick way you can figure that out. Andrew.
It changes from positive to negative.
Ooh, don't say it.
F prime.
Thank you. And this is actually exactly why I don't want you ever saying it in an explanation. What? F. F prime. Something else. So in here, we want to know where f prime changes from positive to negative. And for a minimum, where f prime changes from negative to positive. So I want you to think for a moment. This is the graph of f prime. I want to figure out where f prime changes from, I'm doing the maxes first, where f prime changes from positive to negative. This is f prime. I want to know where f prime changes from positive to negative. Thoughts? One person has thoughts. Two people have a thought. Three people have a thought. Let's go with Alexandra. The x-intercepts, all of them?
All of them
Except for 0 and?
0.
Tyler? Where they're changing from what to what? Okay, I've got an x-intercept over here. Are my f prime values changing from positive to negative? No, they're changing negative to positive there. I think over here, my f prime values are changing from positive to negative, so I think that one is good. I don't think that's happening at x equals 6, so I think there's only one place where f will have a relative maximum. At x equals 4, give me 2 seconds, and I'm going to say why? Because f prime changes. That was just my initial thinking over here. I'm going to say where f prime changes from positive to negative. Andrew.
It says or, do we need to differentiate between the maximum?
Yeah, and I will ask you to do that on like a test or a quiz. Yeah, so maybe that was part of the issue before. I just want to go with maxes first. Where does a maximum happen? Where f prime changes from positive to negative. I'm looking at the graph of f prime. I want to know when those y values change from positive to negative. I see that at x equals 4. So where are the minimums? Please talk to me. 2 and 6. X equals 2, x equals 6. Why? Because f prime changes from negative to positive. There. I do have a question for you. Can we say that the maximum is 4, you can't see that, is 4 comma 0? What's wrong? I see 4 comma 0 there.
Because that's not the original function.
You know that to find y coordinates, you're plugging into the original. You're finding f of 4. Do you have any way of finding f of 4? No, you don't know f. Later on, in certain graphs, we will learn a way to find y coordinates, but we need our whole other big topic of the course, integrals, to figure that out. Not right now. That's also why the direction said, at what values of x, not like where are the coordinates of the maxes and mins. Moving on. Letter C. Where is f concave up or concave down? What is the definition of f being concave up? And use your little yellow card if you need to. Or maybe you just know. Good. I'm looking for where f double prime is positive. And for where it's concave down, I'm looking for where f double prime is negative. Now, give me a moment to write. I want to know where f double prime is positive. That'll be the concave up part. This is the graph of f. I want to know about f double prime. If you have f and want to know about f double prime, its derivative, what are you looking at? The y values or something different?
Slope.
Sorry, I wasn't clear who I was picking. I don't know who I was calling on. We're going to be looking at the slope. I'm looking for where this thing has a positive slope, because the derivative of f prime is f double prime. So I think I care about between 1 and 3, 5 and 7, and I think 8 to 9. I'm going to say 1 to 3, union, 5 to 7, union 8 to 9. Why? Because f double prime is positive. Do concave down, and then I need to fix an issue with the last video that I recorded, which is why we're doing this way. So I can get the graph in there too. Hopefully you're saying 0 to 1, 3 to 5, 7 to 8 because f double prime is negative. Here's the issue that I need to just sort of fix. The College Board used to be okay with this for justification. They're actually no longer okay with this for justification. What they are saying, so I think we should absolutely have this. I just need to add a little bit more onto it. What they want is justification that always goes back. I think we're going to shut the door. What they want is justification that always goes back to the graph you're looking at. How are you figuring this out from the graph of f prime?
You look at the slope.
So I'm looking at the slope. What they're going to want you to say, f double prime is positive, where I see f prime increasing. That's what they're going to want for your justification. How do you know f double prime is positive? Because f prime, am I on the screen? Thank you, is increasing. And they actually absolutely need that second piece. You have the graph of f prime, so somewhere your justification has to tie back to that graph of f prime that you're looking at. Concave down under those intervals because f double prime is negative. How do I know f double prime is negative? Because f single prime is decreasing. So I feel like your yellow card is going to be a place to start, but it doesn't have those pieces of the definitions on there. We have got to get that by, I'm looking at f prime, how do I figure out my f double prime stuff? Logic like that.
So when you ever have the graph of f double prime,
Let me do letter D, and then we'll go on to problem 2. Look at problem 2. Yes, of course. Letter D, x coordinates of points of inflection. How about you take a moment, write down your definition of f having a point of inflection, and see if you can think about where we will have points of inflection. Bless you. I hope you said f double prime's changing sign. You have the graph of f prime. Where is f double prime? Hands, please, if you have an idea about this. You have f prime. How would you figure out where f double prime is changing sign? You have f prime. I want to know where f double prime changes sign. 1. Andrew, what do you think?
Where f prime of x has a slope of, where f double prime is 0, and so at the relative max or min of f prime of x.
Yeah, I think over here, this is one place where f will have a point of inflection because f double prime is changing sign there because f prime is changing from decreasing to increasing. Okay, let me write down a couple things. I think I've got points of inflection at x equals 1. Where's the next point of inflection where f double prime, the slope of the graph you're looking at, is changing sign? 3. Then where? 5. Then where? 7. Then where? 8. Okay, here we go. I have x equals 1. I have 3, I have 5, I have 7, I have 8. Why? Because f double prime changes sign there, which is how I would have explained this before the College Board really said you gotta tie those explanations into the graph you're looking at. Because f prime is, I think I already maybe said this, because f prime is doing what at those places? Changing how? How's f prime changing at x equals 1? Yeah, I need a little bit more than that. Well, so over here at x equals 1, I think f prime, no, yes, I think f prime, the graph I'm looking at, is changing from decreasing to increasing. I think at x equals 3, it's changing from increasing to decreasing. I think our justification is going to be, okay, where f double prime changes sign, because f single prime changes either from increasing to decreasing or decreasing to increasing. That will be good enough, and I don't think I really need to separate the two of those, because f prime changes from increasing to decreasing or decreasing to increasing. I wanted information about f, and I had the graph of f prime. To figure out where the original is increasing, decreasing, has relative maxes, relative mins, we look at f prime, which is the graph we have, so I'm just looking at the y values. To figure out where f is concave up or concave down, you need to know about f double prime. Is it positive or negative? Well, if we have f prime and want to know about f double prime, we're looking at the slope of f prime, which means we can talk about f single prime either increasing or decreasing. Increasing where f prime has a positive slope, decreasing where f prime has a negative slope. Similar ideas with our points of inflection. But now turn the page. And actually, you know what? I think I want you just to read number 2 and see if you can figure out what's going on here. This is going to be different than the first page. Have you realized we're looking for where f double prime changes sign? What am I looking for changing sign? The y values on this graph or the slope on this graph?
Y values.
Y values? But I did slope on the previous page to find points of inflection. Why am I looking for where the y values are changing sign?
Because we're given f double prime, not f prime.
All these problems are different based on what you're given. We have f double prime. I want to know where f double prime changes sign. Do you see why that means we're looking for where the y values will change sign? Is anyone with me? Okay, I know you're with me. Is anyone else like? No. Okay, were you with me for problem 1? Okay. Do I need to go back to problem 1 for anyone first? Maybe. The whole thing?
No. Maybe just the last two.
The last 2. Okay, let's go back to those. Then we're going to go and do problem 2 one more time. Where is f concave up and where is it concave down? I'm starting from my definition. F's concave up where f double prime is positive, concave down where f double prime is negative. Is that okay? You've got f prime. You want to know about f double prime. That was my comment about, to use the derivative of the graph we have, look at the slope. I have f prime. I want to know where f double prime is positive. Well, f double prime is positive where the slope of f single prime is positive. That's going to be over here. That's going to be over there. And at the end. That's why I'm saying 1, 3, 5, 7, 8, 9, because f double prime is positive. Similar idea for f double prime being negative. Then I added in the whole College Board wants you to talk about what's going on with f prime. How do you know f double prime is positive? Because f single prime is increasing. Then, points of inflection, that occurs where f double prime changes sign. You have f prime. You want to know where f double prime is changing sign, which means I want to know where the slope is changing sign. Slope's changing sign at x equals 1, at x equals 3, at x equals 5, 7, and 8. Yeah, they happen to be relative maxes. I don't even care about that. They're just places where the slope is changing sign. I'm going to say all that because f double prime changes sign there. How do I know f double prime changes sign there? Because f single prime is changing either from increasing to decreasing or decreasing to increasing. Any better? And you're not just saying that. Turn the page. I want to know where f has points of inflection. This is the graph of f double prime, and I want to know where f double prime changes sign. This goes back to that first bullet point that we wrote on the previous page. To use the graph we have, we look at our y values. I have the graph of f double prime, and I want to know things about f double prime. Bless you. Because I have the graph of f double prime and want to know where f double prime is changing sign, I'm looking for where the graph I'm looking at is changing y values. I'm going to say x equals 1, because my y values are changing from negative to positive there. X equals 4, or no? Yes? No? Give me something. I think no, because my y values are not changing sign there. How about x equals 7? Yes, okay. We're going to say x equals 1 and x equals 7 because f double prime changes sign there. Since I have the graph of f double prime and my explanation talks about f double prime, I don't need to go and refer to anything else like I did with my point of inflection on the previous page. I'm done with my explanation here. And I guess part of the point of this is if I ask you for a point of inflection, it is very different based on if I give you a graph of f double prime or a graph of f single prime or even a graph of f, which we'll get into probably not today but next time, what we're looking for. And this all keeps going back to those 2 bullet points I wrote. To use the graph you have, look at the y values. To use the derivative of the graph you have, look at the slope. Are you sort of with me on how I got the 1 and the 7? Maybe? Maybe? Take a look at number 3. The AP exam loves multiple choice questions like this. Just read number 3 quickly. I'm going to write down my definitions. F's increasing where f prime is positive. Concave up where f double prime is positive. What do you have the graph of? F, f prime, f double prime, f prime, because it said that, right? We're like awake, maybe? No. Do you see how we figured out this was the graph of f prime?
Yeah.
Very good. How did we figure that out? Thank you. Okay, plus it also says the graph of f single prime. There are many places for that. Oh my goodness. I think we need to be done. F prime is positive. You've got the graph of f prime. Do you want to know where the y values are positive or where the slope is positive? You have f prime, you want to know where f prime is positive. Y values. But at the same time, you want to know where f is concave up. You have the graph of f prime, you want to know where f double prime is positive. Slope. Pick out the regions where you have positive y values and a positive slope while I pass out the cumulative review. Very exciting. Oh my goodness. I feel like we're at different excitement levels in here right now. Yes, there is a very wide range of excitement Oh dear. Oh, I'm not there yet. Ask me after class. I want to finish this one, then we can talk about that. What do you think for the answer? Okay, I'm gonna like count to 3, and you're gonna say a letter. Have you picked a letter?
Yes.
I'm gonna count to 3. You're gonna say a letter. 1, 2, 3.
D.
Oh, I like that. Because between -2 and -1, positive y values and positive slope, 0 and... Oh dear. We are going to do way more of this next time. You don't have any homework on this part yet. The homework is just on the second derivative test. I'm going to try to stop the video without erasing everything. Hold on.